Einstein's theory of relativity has been made out to be something that's much more difficult to understand than it actually is. It's also not a theory. It's something that is necessary for the universe as we know it to exist. Basically, it describes that all physical properties are only in existence through the relationship objects have with other objects. I'll give the example, a very simple one, that if there are only two objects in the universe and they're getting farther apart or closer together, you never know which one is moving. So try to imagine that in your head. Only two different objects, like something very basic, like two spheres, and they give the appearance of movement, but the movement can only occur with by the relationship of the objects to each other. If there's only one object in the universe, in a theoretically endless void of space, then it cannot move, because movement can only really occur by the by its relative existence to the position of other objects in space. And it's the same with everything, really. You only really know where you are by the position of other things. And even beyond things like space and position and movement, time works in a very similar way, and I think this is where the concept of space-time comes from. You only know time by the frequency of previous events in your life. You only know how long a day is because the Earth rotates around the sun, but a day is just, it's not like a length of time that would exist if the Earth did not orbit the sun at the exact speed that it does. So I like to think of time as something that separates events and makes frequency possible. Frequency is just like an oscillation, up and down, 1 and 0, on and off. So you only know the day by the night, you only know the positive by the negative, and you only know your own existence by the existence of other things and other people. So that's the basic principle behind relativity. It's described very eloquently by Einstein's example of saying that the speed of light is constant for all non-accelerating observers. To make this simple, there's often the question of, if you're going 99% the speed of light, then what happens, if you shine a light in front of you? And the thing is, if you're not accelerating, if you're at a consistent speed that is considered, however many meters per second is very close to the speed of light, then you're essentially a stationary object. It's very hard to understand, but go back to my example of, if you're the only object of the universe, you can't move. So light, if you shine a light in front of you and there's nothing to reflect it, then you don't see any light. So don't think that it's this esoteric, hard to understand thing when you might hear someone propose the idea that there's no such thing as motion. There really isn't. There's only faster than and slower than. There's no motion that exists by itself. So when you look at, say there's an object in the sky and it's moving very, very quickly, and you suppose it's moving, 1% the speed of light. The speed isn't really important. But with that particular object, it looks to you like it's moving very quickly, but from its non-accelerating, it's not getting any faster or slower reference frame, everything seems consistent. It's, it's kind of like the Doppler effect. You hear something changing in pitch only when it's moving away from you. So the speed of light works in sort of a similar way, I think, in that you only have motion, you only have a consistent speed of light when there is a reference frame that is not accelerating. What I mean by this is, when you're in an ambulance, you hear the pitch of the siren going off, and to you, it's the same thing. It's unchanging, except for, the variation of pitch that is intended. But for someone who's standing still, someone who's not in the same reference frame as you, the pitch seems to be getting higher or lower, based on where they are in reference to the ambulance. Something similar happens with light when you move closer or farther away from objects. If you can imagine the light hitting your eye, if you're moving farther away, then it's going to take a little bit longer for that to happen. If you're moving closer, it's going to take less time. You're essentially adding or subtracting your own speed from the speed of light that's coming off whatever object you're looking at. So what would happen if you were moving nearly the speed of light away from Earth? If you did this for a few days and you looked back at Earth through a telescope, you would only see that a few seconds had passed, depending on how close to the speed of light you were, but it wouldn't be nearly as much time as you had actually been traveling away. So when you go back to Earth, the opposite effect happens. If you were looking at Earth at the same time that you were traveling towards it, things would seem to be moving very quickly because you are going directly into the speed of light. But I don't think that you actually travel time when you do this. You just, you give the appearance that you do once you're way out in space and hardly any time has passed. But when you return to Earth, the objects are still as they are. I mean, you don't want to confuse being able to see things and light as objects as they are, because, as we know, a sun or a star might blow up, and then it would take us years for us to actually know that, because the object giving off the light is no longer there, but its light is still, because there's so much distance in between us, the light is still coming and hitting our telescopes.